we're going to have a look at pie charts. And for the first question, it says, what fraction of the pie chart is labelled gerbil? So what we need to do is we need to find gerbil in the pie chart. And what I'm going to do is just highlight the gerbil section that we're looking at. Now you'll notice there are absolutely no numbers on the diagram. So what do we do? Well, a huge thing you need to remember about circles is that circles are made up of 360 degrees. Why is it 360? It's just a number that's been chosen by people because it has lots of factors. You can divide 360 in lots and lots of different ways. So there's no way to mathematically derive it. You just need to remember the number is 360. Now, with gerbil, we do actually have a clue with gerbil. In the pie chart, we have a little square in the corner, and that's the square for a right angle. So we know that gerbil is 90 degrees. So we're going to make a little note that that's 90 degrees. And so we're going to take the 360 degrees, we're going to divide it by the 90 degrees, and what we get is 4. That tells us that 4 sets of 90 degrees fit into a 360 degree circle. So how do we write this as a fraction? Well, gerbil is 1 out of the 4 possible 90 degree sections. So 1/4 of the pie chart is gerbil, the 1 representing the 1 gerbil section, and the 4 representing the 4 possible 90 degree sections of the pie chart. And to help you, I'll just sketch that on so you can just see where the other sections would be. So I'm just carrying on the 2 lines that make up gerbil, nice and straight. Now, if we were asked about hamster, you'll notice that hamster has a 90 degrees and another lot of 90 degrees and another lot of 90 degrees. So hamster is made up of 3 sections that are 90 degrees. So hamster is 3 of the 4 90 degree sections. And one last note on that, you'll notice that the 1/4 for gerbil and 3/4 for hamster add up to make 4 quarters. They make a whole. Now, moving on to question 2, we have a similar thing based on the diagram above. What percentage of people said they had brown eyes? So again, I'm just going to identify the information being given. We're looking at brown eyes. I'm going to highlight the brown section of the pie chart. And again, we do have a clue here. There's a right angle in the brown section. So we'll be doing the exact same maths. Every single circle is going to be measured in 360 degrees. We're going to divide it by the angle that brown is, which is a 90 degree angle because a little square tells us it's a right angle. And again, that's going to give us 4. So brown is 1 of the 4 right angle sections. And then for the other ones, for green, green's the same. Green is also going to be 1/4, 1 out of the 4 possible right angle sections. And then for blue, you'll notice blue's a different shape. Now, just carry on this line, you'll notice that blue has 1 set of 90 degrees and a second set of 90 degrees. So blue is 2 out of the 4 possible 90 degree sections of the circle. And again, all 3 of those quarter, a quarter, and 2 quarters are going to add to make a whole one. And one last little thing, the 2 quarters for blue, we could simplify that fraction to get a half. So if you see 2 lots of 90 degrees or 180 degrees on a pie chart, that's going to be half of the pie chart. But the actual answer is brown eyes is 1/4. So I'm just going to circle the one that's actually the one we're looking for. Now, looking at question 3, we have throw in a coin and what it lands on. And there isn't really any clues on the pie chart. So what do we do? Well, the centre is not labelled, or is it? Because if we just look through all these questions, on question 1, you can see that all the sections meet in the middle at the centre. Question 2, again, they all meet in the middle of in the centre. Question 4, we can see that as well, and question 5. So every section in a pie chart is going to meet in the centre. That means that for question 3, even though it's not labelled, it's safe to assume that that line does go through the centre of the pie chart. So what that means is that it is divided evenly into 2 halves. And if it's in 2 halves, we can take our 360 degrees, we can share it equally between those 2 halves, and we get 180 degrees. So we now know the exact size of the 2 sections. And because it's exactly half, we know that it's going to be a half for heads and a half for tails when you toss a coin. Now, the question says, what's the probability? So we can't write a fraction as our answer, but 1/2 will be the same as 50%. It says probability is the percentage probability. So fraction probabilities are fine, but if it says percentage probability, we are going to have to write 50%. Question 4 works exactly the same way. So for that one, we can see that it's divided into 3 equal sections. So we can do the same working out. We take the 360 degrees, we divide it, we share it out between the 3 equal sections, and 360 divided by 3 is going to give you 120 degrees. So we now know that all 3 sections are 120 degrees. So it would be a third chance to pick any of those. But the question is saying, what is the angle? So 120 is going to be our final answer. So now looking at question 5, what's the value of the missing angle in the pie chart above? Well, again, we know the full circle is going to be 360 degrees. The clue being given is a small section is 30 degrees. So we take that away from the total, whatever's left over will be the missing angle. So that's going to give us a nice and easy subtraction. It's going to give us 330 degrees. Again, last thing to do, read through the question. What's the value of a missing angle? So I'm just going to circle my final answer. So now for the medium questions, it's all going to be about finding missing angles in pie charts. So for the first question, we've got 120 degrees, and then we've got the section with a little box for a right angle. So I know that's going to be a 90-degree section. So when you're finding a missing angle, you take the total of the circle, always 360 degrees. Take away the sections you do know. We've got the 120 and the 90 that we just worked out. And whatever is left over is going to be that final angle. So 360, take away 120, take away 90, gives us 150 degrees. And I'm just going to circle that just to make sure that is seen as my final answer. So I do have the 90 written on a diagram as well, so it might be ambiguous which one's actually the answer. Moving on to question 2. So again, we've got a pie chart and we have a right angle as a clue. So we'll write that on. Now we only have one angle left, the one we're looking for. We can take 360 degrees, take away the clue we were given at the start, 245 degrees, the large angle, take away the 90 we've just found, and altogether, that is going to give you 25 degrees. And it is worth just thinking, is that a reasonable answer? And you can see that's quite a small angle, and it's also quite a small section on the pie chart. So it does look like that is reasonable. It's also smaller than the 90 degrees, whereas in question 1, the 150 is larger than the 90 degrees. And it's also, it looks like it might be a little bit larger than the 120 as well, but maybe this diagram's not drawn to scale because it does look a little bit equal. So just be careful. If it's not drawn to scale, like question 1, exam papers will say that it's not drawn to scale. So you'll know that the numbers might not match up with what's on the diagram. Moving on to question 3 and look for any clues. We've got 105 degrees, then we've got a right angle and a second right angle. So a longer calculation this time, take 360, take away the clue we started with, we have a 105-degree angle, take away the 290 degrees we just found out, and if you take all of those away, you're going to get the answer, which is 75 degrees. And again, is that a credible answer? Well, it is smaller than the 90-degree angle, so it looks like it's going to be roughly correct. Question 4 is getting a little bit more difficult. Look for the clues, and we have the 90-degree angle, but there's nothing else, and everything else is labelled using algebra. Now, we can use the same method. So we take 360, we take away the clue that we have, the 90 degrees, and that's going to give us 270 degrees. Now, if you have multiple angles left, what's going to happen is the 270 is not going to be the size of one angle. It's going to be the size of all of the remaining angles, every single one of them. So what do? How can we split the 270 fairly between those 4 remaining sections? Well, we do have the algebra in there, so let's add up the algebra. So we have 2x, we have the x, a second x, and a second 2x. And if we add all of those together, that is going to give us 6x. So now we can form an equation. 6x is the same size as 270 degrees. So what we can do now is using our solving equation skills. So if 6 lots of x is 270, one lot of x is going to be 6 times smaller and it'll be dividing by 6. And 270 divided by 6 is 45 degrees. So if x is 45 degrees, so we have two sections that are both 45, we can label those now. 2x will be double that, and 2 lots of 45 is going to give us 90 degrees. Now, our 90 degrees angles do look smaller than the 90 that was given as a clue. So this is going to be a diagram that is not drawn to scale, because if it was drawn to scale, you could solve this without the algebra and immediately spot that the 2x was 90 degrees and make the question a lot easier. Moving on to question 5, we want the angle that the purple and black segments add up to. And again, we don't have any clues for those, but we do know that the green section is 90 degrees because of the labelled right angle. So again, what we can do, even though we have 2 segments remaining, we can use our method, the total size of the circle, take away 90 degrees to give us the 270 degrees. And so what that means is that the 270 degrees is the size of the 2 remaining segments. Now, if there's more than one segment remaining at the end, then you do need to do some extra maths. So we know the total is 270, and that's actually what the question is asking us for. So we can write 270 as our final answer. But what other maths could we do here? Well, it looks like the purple and black sections are the same size. Let's just imagine that that is the case for a little follow-up question. So I'm going to label the angles for purple and black. And to show the same size, we'll put a little dash on the angle to show that they are the same size. So what could we do? Well, we could set up an equation. We don't know the size of black. Let's call it x. We don't know the size of purple. We know it's the same size of black, so we can call that x. And so we can set up our own equation. So we know that 2 lots of x are equal to 270 degrees. So if I half that, we know that 1 lot of x is going to be half of 270, which is 135 degrees. So now we know the size of all of the angles there. And the last thing we do is just pop those on the diagram. And all 3 sections should add up to 360 degrees. Moving on to the hard questions, we're going to look at putting some values into these pie charts. So for the first question, the size of the angle that represents brown and red is the same, and orange is half the size of the red segment. So before I move on, I'm just going to kind of express this using some algebra. So orange is the smallest segment, let's call that x. We're then told that orange is half the size of red, so red's double the size of orange, so red must be 2 lots of x. And then we know that brown is the same size as red, that is also 2x. So altogether, the 360 degrees in the pie chart is equal to 5 lots of x. That's what all 3 of the angles add up to in algebra. So now we can find the size of 1x by dividing by 5. And 360 divided by 5 will give us 72 degrees, which is 1 lot of x. So now we can identify the size of all of the angles. So the orange angle is 72 degrees. The brown is twice the size of that. That'd be 144 degrees. And red would also be 144 degrees. And it might be worth, just after your calculation, add up all 3 and make sure they do add up to 360 so you know you've got it right. Now I've worked out the size of all the angles in the question, I can move on. And now it says, if there's 36 red balls, how many balls are there altogether? So what do I know? Well, I know that the 36 red balls are the same size as the angle for red, which is 144 degrees. So what I want to do now is find out the size of 360 degrees worth of red balls. So how can I get from 144 to 360? Well, I can't without a lot of effort, but what I can do is go via 1 degree. So we're going to do 36 divided by 144 to get 1 degree's worth of red balls, and that is 0.25 or a quarter. 1 degree represents 1/4 of a red ball. So if I want 360, I can now multiply that by 360, and that gives me 90. So I know that if there are 36 red balls, how many balls are there altogether? There are 90 balls. So a big thing with pie charts and numbers in pie charts is to always find what 1 degree worth is by dividing, and then you can scale it up to whatever you need by multiplying. So question 2, the number of balls in a bag is recorded in the pie chart. There are 444 balls in the bag. So then how many are not orange? So again, let's just have a look and see what clues we have. So we know that we have the red section is 90, it's got a right angle. The orange section is also 90, and white is the rest of it. It must be 180 to make it all add up to 360. Now, what do I know about the numbers? Well, 444 is the total number of balls in the bag. So that's going to be equal to 360 degrees. So let's find out how many are represented by 1 degree. So we take 444, divide it by the 360 degrees that represents to get 1 degree. And I'm getting 1.23 recurring. So that's quite an awkward decimal. Now, what am I looking for? I'm looking for how many are not orange. So let's just highlight that. So I'm going to highlight everything that isn't orange. So the red isn't orange. That's 90 degrees. And the white isn't orange. That's 180 degrees. So altogether, the 180 and the 90 is going to give us 270 degrees. So what we do now is we take our 1.23 recurring. If you delete that number off your calculator, do the calculation again to get it back on your calculator, multiply it by 270, and I'm getting 333. That's the number of balls which are not orange. I guess write down a final answer. There's a lot of numbers on this. It's 333 balls. Moving on to question 3. The pie chart represents the number of people who own pets. There are 32 people who own a dog. How many own a cat? Okay, so again, firstly, just look at the angles and forget the rest of the information. 40 degrees is cat. How many degrees is dog? So we are going to take 360, take off the 40, and whatever's left over will be dog, which is 320 degrees. So always work out the size of the angles first. Then we're going to write down what we know. So we know that the 32 people who want a dog are equal to the 320 degrees. So my first step is working out the size of all the segments of the pie chart. The second one is relating the kind of figures, the numbers we're given as a clue to the actual number of degrees. And what we'll need to do is we need to find the 40 degrees who own a dog, and we're going to go via 1 degree. So we do 32 divided by 320, which gives us 0.1. That means that each degree represents a tenth of a person. And then we multiply that by 40, and that gives us 4. So we know that 4 people own a dog. Let's write in a final statement to show that. Moving on to question 4, again, same method, look at the angles first. Green is 120 degrees, so what's purple going to be? So we take the 360, take away the 120, and that should give you 240 degrees. Now we know how large all the segments are, we can have a look at the number we're given as a clue. And we're given that there are 14 green balls. That corresponds to the angle for green, which is 120 degrees. Now we want to know how many there are in total. So the total would be the 360 degrees. Now what you could do is follow the same method, take the 14, divide it by 120, and then you can get 1 degree and then multiply that by 360 degrees. But you might spot a shortcut here, and the shortcut is that 120 is actually a factor of 360. So you can shorten this by just doing 14 times 3, because 3 lots of 120 go into 360, and that gives us 42 as our answer. Now, if you can't see the shortcut there, that's absolutely fine. Just do it the way you've been doing it. So find 1 degree by dividing by 120, and then scale it up to 360 by multiplying by 360. You can spot little shortcuts like that by looking at factors and multiples. It will save you a little bit of time. So now let's write down our final statement. There are 42 balls. Moving on to question 5, we have a pie chart. The white section is 200 and 52 degrees. So let's make a note of that on the diagram. What else do we know? Well, pink is going to be 90 degrees, and we don't know red. So before I read anything else for this question, and we'll work out how large red is, because I'm assuming that's going to be important. So we take 360 degrees, always a total for a circle. We take away the clue for the white section, 252. Take away the right angle for pink, and whatever is left over is going to be the size of the red angle. And I'm getting 18 degrees. So let's label 18 degrees. Now I've got all the sizes and have a look what else it's saying. What's the probability of picking a red ball out of the bag? So I need to write this 18 degrees as a probability. Now, probabilities, you take the thing that you want. I want the 18 degrees, and it's over the total. And the total for a circle is in degrees. So the total for the circle is 360 degrees. And what we can do is we can simplify this fraction. Now you can do 18 divided by 360 on a calculator, and that will give you 0.05. Or another thing you could do, simplify the fraction, is divide 360 by 18, which will give you a fraction which is 1 over 20. Now you're working, it doesn't really matter which one of those two you write, but does it ask us for anything specific? So what's the probability? It doesn't mention fractions and it doesn't mention decimals. Either of those would be acceptable. You even might spot that 0.05 is the same as 5%. So it doesn't specify. Any of the three versions of that answer are going to be absolutely fine. But sometimes it will say, please write it as a fraction, or please write it as a percentage. And you might have a mark for transferring between the fractions and whatever it's asked for.